Ellipse, conic section, parts 3. Okay. In ellipse, you can see this is the diagram of an ellipse. As you know better about the shape of an ellipse. And here in parabola, we have seen, if you will see this point and this line. Okay, so half of this you will find it is not an parabola. In parabola, this line is not coming down, it is going up and up to infinity. Parabola, this line is from A to, is moving like this, and here it is from this, it is moving like this. Parabola we have seen, or this side, because the distance is same. In that case, this is not that one. Okay, so here is different case. Here that we have seen in parabola, fixed line, one fixed line. Here you will find two fixed lines. Fixed line, that is Z and Z dash. These are two fixed line. These are called directrix. There are two directrix. One is this side, one is this side. And the point P, this point is moving from the fixed point. So you will find two fixed points. One fixed point is this one is this one. So similarly, this is also directrix. So you will find two things. Everything will be twice in a pair here. Not everything, generally focus and this these two lines. And S dash, these are two focus. So foci, though they are plural is foci. So the S and S dash are two. This is a focus, and this is also a focus. Okay. So this point is moving. If you see, starting, this point is starting from A and moving like this and making a figure. Okay, this P point is the movable point. So this point, if you will see, this distance is more. Is this distance is what? Whatever this distance PS and PS is the starting from here is this one, and this is PM from this. So PS is more. If you see that PS here, PS distance is more than PS is more than PM, right? PS is more than PM. So that means we can say PS upon PM, PS upon PM is greater than 1. So PS upon PM is the eccentricity. This is called the eccentricity, distance of a point from the focus to the distance from the fixed line. This ratio is called eccentricity. So this eccentricity is greater than 1. But in case of parabola, it was 1. So eccentricity is greater than, this is called eccentricity, and eccentricity is greater than 1 for ellipse. First thing. And we have seen the directrix. This is a focus S, and this is also S dash. So its coordinates will be minus AE. AE. E is the eccentricity, which is equal to PS upon PM. So here the left focus will have your left focus will have the points, means coordinates, minus A, E, and 0. And right focus will have plus A, E, 0. And these two are directrix. Directrix. One directrix help. This equation of this directrix will be x is equal to A upon E, and x is equal to minus A upon E. Okay. And its equation of this ellipse will be x square upon A square plus y square upon b square is equal to 1. A, what is A? This distance, this is major axis from A to A dash. I'll change color. This is this distance to this distance, A to A dash, A dash, A dash, A dash is major axis. A dash is major axis, and B dash, B to B dash, this whole distance from B to B dash is called minor axis. Minor axis. So this is called minor axis, major axis and minor axis. And this major axis A to A dash, this is dash. So A to A dash is equal to 2A. Major axis, length of major axis we are taking 2A. Length of minor axis we are taking 2B. So that means this is the half, this is the origin, and this is x axis, x, O, x dash, and this is y axis. They are meeting at origin O. So from O to A, from O to A, this is A. So both the side, this is A, this is A, and this is B, and this is also B. So half of the minor axis is B, half of the major axis is A, and that is why its equation is x square upon A square plus y square upon b square is equal to 1. And you can see that in this equation A is greater than B. Vertices and major axis, minor axis, that we have seen in the figure. Now equation for this ellipse will be equal to x square plus A square, x square upon A square plus y square upon B square is equal to 1. This will be the equation. Okay. And A is greater than B, because major axis is x axis. You have seen this is an ellipse, this is horizontal ellipse, we will see vertical also, and it is on the x axis, x dash. So this is major axis, A dash is major axis, and B dash is minor axis. So a major means bigger, so major axis is greater than minor axis. Length of major axis means it will have two axes. When you see the ellipse, it will have one axis, this one axis is this B dash. So A dash is greater than B dash. Obviously one is major, one is minor axis. So A is greater than B. And this A and A dash, as I told you, this distance is A. So therefore the coordinates of this will be what? A0. and the coordinates of this is a distance minus a distance because this is origin. So the coordinates of a dash will be minus a 0. So that's why the coordinates of these a and a dash are called vertices. There are two vertices, a 0 and minus a 0. And length of major axis, I told you 2a, minor axis is 2b. And the main important point is here the relation between eccentricity. This you have to remember. E square, either in this way or you can write multiplication form, whatever it is. And eccentricity, okay, one we have taken opposite type. Yes, sorry. This is eccentricity is less than 1. Ps is greater. So this is we have taken opposite because the length Pm upon Ps will be Pm because Pm is less than Ps. Point will come here. So this is Pm. Pm is less than Ps. So Pm upon Ps, distance from the fixed point upon distance from the focus. That is eccentricity. There is less than 1. So eccentricity is less than 1. It will come again. So this relation, you have to remember this relation for this parabola. We are talking about this is called, you can say, horizontal parabola. Another will come vertical parabola. So all the things will change. Horizontal ellipse, sorry, horizontal ellipse and then vertical ellipse. So b square is equal to a square 1 minus e square means 1 minus e square. So eccentricity is less than 1, so it will be subtracted from 1. In hyperbola, it will be reversed. So this you have to remember. This will be used if A is given, major axis is given, eccentricity is given, or sometimes we have to find the eccentricity, then we will use this formula. And as I told you, foci of the ellipse are AE minus AE0. This is foci will come somewhere here as S and S dash. So S, the coordinates of S will be AE0 and coordinates of S dash minus AE0. Directrix, equation of the directrix, I told you the equation of directrix means both the fixed line will have this, and since the center of a conic section at a point which bisects every chord, therefore, in the case of ellipse, every chord through C is bisected at C, therefore C is the center of the ellipse. C is the center of the ellipse, that is 0 that we have seen. Eccentricity, E square is equal to A square. I told you this relation, and when you solve this relation, you will get E square. You can remember by this way also, E square is equal to A square is taken this side, and then E square is also taken that side. You will get E square. So E square is equal to, you can write 1 minus major axis upon minor axis whole square, or you can use this half of the major axis. Ordinates and double ordinates and latus rectum. Ordinates, x coordinate is called abscissa and y coordinate is called ordinate. So P be the point on the ellipse, let Pn be the perpendicular to the major A dash and Pn produce meets the ellipse at P dash, then Pn is called the ordinate of P, and Pn, P dash, the double of the ordinate to that distance. Latus rectum, yes, it is having double ordinate passing through the focus means left side also passing through the focus. You have seen this is, yes. So this is the focus. This is also the focus. So the perpendicular line passing through this L, L dash or this side, both are called latus rectum. And the latus rectum, length of latus rectum will be equal to 2b square upon a. Just you remember this. Length of latus rectum will be equal to 2b square upon a. No need of this. You can, so length of latus rectum of ellipse 2b square upon a. A is greater than b. Focal distance means the distance from the focus. This is a point on the ellipse. So from the focus to this point, this distance is called focal distance. Okay. And there are two focus. So this point will have the distance from S and this will also have from S dash. Okay. So there is a relation also between these two distances. SP plus SP dash is equal to major axis always. This will be always equal to major axis. SP plus S dash P or PS dash is always equal to the 2A major axis. Okay. So equation of ellipse we have seen, this relation we have seen. Now we have vertical ellipse. Before going to vertical ellipse, you can go through this table. This table is showing everything. This is we have studied. This is first one is this is horizontal ellipse. Horizontal. In this ellipse, center is 0, 0 as we have seen. Coordinates of vertices a0 minus a0. Coordinates of foci is this one, length of major axis, length of minor axis. Equation of the major axis means x-axis, that is y is equal to 0. Equation of minor axis is x is equal to 0. Equations of direct axis are x is equal to plus minus a upon e. Eccentricity is this one. That relation you can remember by this way or that way. E is equal to under root 1 minus b square upon a, length of latus rectum 2b. Focal distance of a point. Any point which is from at a distance, some distance from the focus. So you can find, if you know AE and x coordinate, then you can find this one. Now the main important thing that we will discuss now, there are different books. In different books, they are taking the equations in different ways. So please do not confuse and do not follow different books. You have to follow either whatever I am telling you, like that you can follow for vertical ellipse. It is very confusing for the student if they are following two books and different forms of the. Actually, what is the difference here? If in some books here A is, you can see A is greater than B, and here A is less than B. So that means 2B here, 2B will become major axis. Try to understand. 2B has become major axis because B is greater than A. Okay. So and 2A is minor axis. In some books, they are not making A as minor axis. They are not changing 2B and 2A. 2A is, they are making this. See, this is the vertical ellipse. If this distance depends on us, we can take again 2A. If we are taking again 2A, if we are taking again this 2A, then the equation will change. Then equation will change. The equation will become x square upon b square plus y square upon a square. Okay. So my suggestion is you can follow this one. Here you can see that whether a is greater than b or a is less than b. So accordingly, you have to check this equation. You will use this equation only. Okay. And if you are taking a as a
major axis, that means 2a as a major axis, then equation will become x square upon b square plus y square upon a square is equal to 1. So in this case, the formulas will be same, only the coordinates will be changed. Instead of b, then a will come. So I think we should follow this one. This one is better. Instead of changing, we should follow this one, that now if major axis is in vertical, the major axis we will take 2b. Okay, understood? Major axis we will take 2b. This distance we are taking from this to this, we are taking 2b, and this distance we are taking 2a. In this case, 2a is greater, a is less than b. When a is less than b, the equation will be this one. Now you can see that everything will be changed because focus will come here, and here vertices will come, major axis will come a to a dash, b to b dash, like this. So then only the change is here, instead of a, b will come. B and a will take the means place of b, but this is this is on x-axis, this will be on y-axis. Therefore, obviously the x coordinate will be 0. So focus vertices will be 0, b focus will be 0 plus minus e. Major axis we have taken 2b, minor axis 2a. X is equal to equation of the major axis. Equation of the major axis now. Equation of major axis x, y axis, yes, x is equal to 0, correct, y is equal to 0. Equation will be y is equal to plus minus b upon e, and the relation will be reverse eccentricity is equal to 1 minus a square upon b square and 2a square upon b. So b is equal to plus minus ey. So just remember this, these formulas. We can complete the exercise. We can complete the exercise in the next class. Okay. So we cannot start now exercise because 2-3 minutes are left. So next time we will start. So just you remember, this is horizontal parabola, and here we are taking horizontal parabola, ellipse, sorry, horizontal ellipse, and this is like this horizontal, and we are taking this length as a major axis 2a. But this you have to remember. And here we are taking major axis as 2b. Changing, so therefore the formula will be changed. A is replaced by b, or if somewhere a b both are there in eccentricity, 1 minus b square upon a square, it will become 1 minus a square upon b square, and 2b square upon a will change to a square upon b. Or if you will change here, if you will not change major axis, then your formulas will be same. A will be a, and formulas, all formulas will be same. If you will take major axis as 2a. So it is up to you, whatever you can follow, but I think we will follow this one.